Hello everyone, this is Mrs. Figueroa again, and we're going to be going over spheres today. So spheres are like our ball shapes. They're circular, they don't have any rough edges, it's all round. So all we need for today's lesson is going to be our radius. So for the objective today, students will be able to find the surface area of spheres. Okay, so for concept today, we're going to be looking at what it means to have the sphere. So like I said, the sphere, surface area of the sphere, is the measured area of the curved surfaces of the sphere, because we don't have any like flat edges or anything in the circular sphere, okay? So all spheres are similar, meaning they're kind of just like proportional. They're the same shape, they're just could be different sizes, okay? So same shape but different sizes. So the formula for the surface area of a sphere is only dependent upon the radius, okay? So surface area of a sphere is only dependent upon the radius of the sphere. The radius is measured from the point at the center of the sphere to the surface of the sphere, okay? So if you notice at the very center here, inside the ball, if you think about like if having a ball and right in the very middle, that's the center point, and if I draw a segment from that center piece all the way to the edge of the circle, that is called my radius, okay? So then the formula used to calculate the surface area of a sphere is S is equal to 4 pi r squared. So notice I just have the radius is basically my unknown, okay? Where r, again, is the radius of the sphere. All right, so let's look at the first example here, and my directions again says to find the surface area of each sphere. So remember the formula is just S is equal to 4 pi times the radius squared. So the only thing that I need to know is the radius. And if we look at the picture here, I have a full segment, so that means the 5.6 is actually the diameter. And remember, to find the radius, you just take that divide by 2. So then the 5.6 divided by 2 is going to give us 2.8 feet for the radius. So all you do now is just plug it in. So I have S is equal to 4 pi times my radius is 2.8 squared. So then in your calculator, you want to do the squared first and then multiply by 4. And remember, we want to find the exact answer first and then find the approximate answer. So we're going to do 2.8 squared gives you 7.84, and then multiply by 4. That gives you 31.36 pi, and then the units is feet squared. Okay, so again, that's the exact answer. You want to eat your dessert at the end. Leave the pie until the end. So then this is going to be 31.36 times pi, and then your approximate answer is going to be 98.52. It doesn't say what to round to, so let's just say 98.5 square feet, or feet squared, and that is your those are your two answers, the exact answer and your approximate answer. It doesn't say to give both answers on the answer key. I think you're most likely only going to find the 98.5, but I always like to write my exact answer and the approximate answer anytime I have like cylinders, cones, and spheres. All right, so now let's look at the second example. This one's pretty straightforward. You have the radius, so you just plug it in. S is equal to 4 pi times the radius squared. Go ahead and pause the video and then try this one on your own, and then replay the video to check your answer. Alright, hopefully you paused the video. So here's the solution. The radius is 15, so you just go 15 squared, and then multiply by 4. That's going to give you 900 pi centimeters squared is the exact answer. And then if you take 900 times pi, that gives you your approximate answer, 2,827.4 centimeters squared. All right, so now let's look at the lateral area of the hemisphere. So we have this thing called the hemisphere, and it's just basically half a sphere. So hemi means half, and then a sphere. So lateral area, remember, lateral area does not include the base. Okay, so for my lateral area formula, notice again, it's not including the base. So if I have the surface area of a sphere, that's 4 pi r squared, we can create the formula for the surface area of a hemisphere. So the lateral area, meaning not including the base, it's going to be half the surface area of a sphere. So if you think about having like a plastic ball and you cut it in half, it's going to be like hollow on the base. So you're cutting it in half, so just take half of 4, gives you S equals 2 pi r squared. But again, it's no base. Your circular piece right here is going to be hollow. There's not going to be anything in this piece. All right, so again, this is lateral surface area, meaning the lateral does not include the base. So now let's look at the hemisphere, surface area of a hemisphere, which means you are going to include the base. So surface area is the base included. So it's going to be half the surface area of a sphere plus the area of the circular base, because you're going to add the base to it, okay? So we have S is equal to half the sphere plus the circle area is pi r squared. So we have 2 pi r squared plus pi r squared. So I have 1 pi r squared plus 2 pi r squared. That's going to give me a total of 3 pi r squared. Okay, so the difference between like surface area of a hemisphere and the lateral area of a hemisphere is, if you think about, like, let's say you have a Tupperware, a round Tupperware, and it has a lid on it. So the ones with the lid, that would be the surface area, versus the one without the lid would be just the lateral area, because you're not including the bottom, okay? But in this one it says surface area, meaning you do include the base. You're gonna have like a lid here. It's not gonna be hollow, okay? So let's look at an example. This one is asking for the lateral surface area, meaning no base. Okay, so lateral means no base. So I have my formula, S is equal to, you have to figure out if it's 2 pi r squared or 3 pi r squared. So S is equal to, I don't have the base, so that's less things that I'm going to add, so it's the one with the 2. So it's a 2 pi r squared. And if you look at the picture, I have half the segment, so that tells me that is the radius. My radius is 12, so just plug it in. I have S is equal to 2 pi times 12 squared. And then you're going to take your calculator, 12 squared, multiply by 2, and then leave your pi until the end. That's going to give you S is equal to 288 pi inches squared. Remember, eat your dessert at the end, leave the pi until the very end. So S is approximately 288 times pi is going to give you approximately 904.8 inches squared. So those are my two answers, the exact answer and the approximate answer. But again, on your homework, I believe you're only going to see this 904.8 inches squared, for example. Okay? All right. So now let's look at the next example. It's pretty much the same. This is asking for lateral surface area, meaning again, no base. So the formula is S is equal to 2 pi r squared. Okay, so all you need is the radius, but be careful, here is the full segment, so that means this is actually the diameter. Okay, so then the radius, remember you have to divide by 2, so 23 divided by 2 is going to give you 11.5 feet for the radius. So go ahead and pause the video and then try this one, see if you get the correct answer. Once you finish, go ahead and replay the video to check your answer. Alright, so hopefully you paused the video. So here's the solution. Your radius again was 11.5, so just plug it in, square 11.5, and then multiply by 2. It gives you 264.5 pi feet squared. So then if you multiply by pi, you get 830.95, but if you round to the nearest tenth, that's really like 831.0 feet squared. Okay? Alright, so now let's look at the next example. This one says find the surface area of each hemisphere. So surface area means including the base. Okay, so now I'm going to add another circle to it. So because I'm adding the circle to it, this circle here, I have to go add a pi r squared to my formula. So s is equal to 3 pi times the radius squared. And again, all I need is the radius, which is given to me in my picture. I have half the segment, so that is the radius. The radius is 5 centimeters. So just plug it in. We have s is equal to 3 pi times 5 squared. Okay, and then just multiply. S is equal to 5 squared gives you 25. And then 25 times 3 is going to give you 75 pi, and then your units are square centimeters. And then you can eat your pie, you can eat your dessert. So we're going to do 75 times pi, and that's going to give you 235.6 square centimeters for your answer. Okay, pretty straightforward. Now let's look at the next example. It's still surface area of a hemisphere. It's pretty much the same. Surface area meaning including the base. So my formula, I'm going to add the pi r squared, an additional pi r squared. So that's going to be 3 pi r squared for my formula. Okay? And be careful again, this is the full segment is drawn, which means this is the diameter. So to find the radius, just take that divided by 2. So 28 divided by 2 is going to give you 14 feet for your radius. So go ahead and try this one, pause the video, and then replay it to watch the solution. Alright, so hopefully you paused the video. Here's the solution. The radius was 14, so if you just plug in 14 squared times 3 gives you 588, and then multiply by pi at the end, you should have had 1,847.3 square feet. And that is our last example for today. Make sure you do the homework and turn it in on time, and we'll catch you guys next time.